So let's look at the code again that we're using our list comprehension. And you can see I've changed it a little bit. Down here on line 107, I've written a method called announce. And now what it does is if you pass an item to announce, it simply returns that item back. But along the way, it does a print statement to let you know, hey, I'm processing this particular item. And you can give it like kind of a little descriptor. So over here, when we're going through the 2-bedroom homes, each time through the test, we're going to go through all the homes. It's going to say, hey, tell me what home you're processing. Oh yeah, and continue with the regular test, yeah? And then later on, I decide, hey, I only want to process the first 5 2-bedroom homes. Now, the way this processing works is almost identical to the challenges that we ran into in application number 8 when we were doing text searches across gigabytes of text files. Remember, for small quantities of data, this mechanism where we had functions that recursively searched directories and files, and each time it hit a file, it would create a list, put all the matches in there, and return it up and build that up into an entire set of search results for the whole directory structure, and then at the end, pass that list back with all the matches. That worked fine for megabytes of text files. For gigabytes of text files, the memory went crazy. It took forever. There was all kinds of problems. And you'll see that this is identical in its sort of processing characteristics. And that should be no surprise because this list comprehension is very much like create a list, loop over it, fill it all the way up, and then here's the answer. Remember, our solution was to use generator methods, the yield keyword, and it would sort of on demand as the client would pull, doing a loop, a foreign loop, or some kind of processing of the end result. It would one by one pull those results back. So we can use this thing called a generator expression to move from the list call and await style to this yield return coroutine style, but in the list comprehension and what we'll call a generator expression style processing, where it's just not a method with the yield keyword, but it's just an expression on a line. Now, the way we do this is remarkably easy, but before I do it, let me show you how the processing works here. So if I run this, you'll see even though we're only processing 5 homes, we're going through, look at this, every single home, we basically process the entire data stream, and then we go back and, oh, actually I only wanted the first 5 2-bedroom homes. What would be much better is to just stop after we get to the first 5 2-bedroom homes. So what do we have to do to change this? Well, for lists, you use square brackets. For what we call generator expressions that have this yield behavior, this coroutine behavior, we just use parentheses. That's it. We do nothing else. Now, this, you cannot index into those things anymore or slice them, which basically uses indexing. So I'm going to need to create a little list. So it's not a perfect analogy how we can flow these strings through, but we're going to use this as sort of the step to say, hey, we're going to stop after we get just 5 of these. And we don't really need this anymore, do we? Because that's actually doing the same thing. So remember, previously, this part right here went through the entire data structure. Let's try again. Okay, so we're still pulling in the 5 items down here. But as we go through it, you can see there's a lot fewer. We just go until we have enough 2-bedroom homes to run through here, and then we stop. We don't have to process the whole data set. And down here, we can get the average and stuff. The averages, of course, are different because we're not averaging across all 2-bedroom homes. It's just the first 5. Really, the way we have things structured, this is the cheapest 5 2-bedroom homes. In fact, there's a few more places where we can use generator expressions in our app. So we were using the generator expression up here, but now we're creating the list, filling it all the way up, and then passing that to the mean. No reason to do that. We can use parentheses instead of square braces, and we'll only have one of these little projection pieces in memory at a time for each step. Make our mean calculation a little more efficient. Try it again. See, we get exactly the same answer, different performance characteristics. So you see how we can use list comprehensions and later generator expressions to replace procedural operations with more declarative ones and get the performance benefits of generator methods without actually writing methods at all.